no longer Susan Hendricks. So my new name is Susan Tappan. And I'm staff scientist here at MBS, just like Dan, but I also have a role in MBS Labs, which is our contract research organization. And both Dan and I are intensely interested in stereology as a quantification method.
And that's why we're going to talk to you today about stereology concepts and probe selection.
Yep. As always, we love hearing from you both during the webinar and after. So please submit your questions via the question window, and we're going to address them as we go along. This webinar is being recorded and will be available for viewing later.
Okay, so the purpose of today's webinar, this is really not a beginner webinar for stereology. We're not going to go over things like how to follow the rules and how much sampling to do. We do have other webinars about that, and we can help you out with that type of thing. Today's webinar is kind of to take a step back from that, and we want to demystify the process of choosing a stereological probe. We want to give you our advice, tell you our favorite probes, and what probes we think you should be using that are the easiest and the most efficient to use.
Yeah, so we're really going to be covering stereology from an experimental design perspective. So prior to sitting down at the microscope and getting going, what do you need to think about, and how is the best way to approach your experimental design? So here's the problem. You want to be able to quantify three-dimensional structures. And that could be anything from the number of marbles in a jar to Christelle and Jean-Claude's how much fabric they had to use in order to wrap these beautiful trees in art installation. So that would be an example of a surface area quantification.
It's an odd-shaped figure, it's a star. How can we estimate the volume or maybe the surface area of this solid?
If you're hungry, I mean, it is lunchtime here on the East Coast, so how much spaghetti I have in my dish. How long would my spaghetti stretch?
That's one type of thing that can be estimated. Here we have a loaf of marble rye, and it has two components in it, and somebody may want to know what is the volume of one of those components, or what's the surface area of one of those components. So we should try to show you examples from real life of the types of features that can be estimated, but we're going to be working under the microscope.
Right, and so if you take this conceptual understanding of these features that you want to quantify and then apply them to our lives as scientists, we may be interested in quantifying, say, the volume of the cortex, or how many neurons there are in the cerebellum.
Sue and I are both neuroscientists, so we tend to think of the brain a lot, but obviously stereology can be used in any organ. You may be interested in something about the blood supply to the heart, so the length of the capillaries may be of interest. There's a lot of membranes that biologists are interested in. What's the surface area, for instance, the maternal-fetal interface in the placenta?
Right, and so we're going to be discussing all of these in the framework of how do you estimate these 3D parameters on tissue sections. So when you can't observe your entire parameter in its entirety just by looking at it, you need to section it up.
So the solution to the problem, we think, is unbiased stereology.
Absolutely. On the right is one of my favorite cartoonists, XKCD, and this one just makes me giggle when I see it because it illustrates the difference between, say, a normal person and a scientist. So you get shot pulling the lever, and if you're a scientist, you might say, I wonder if that happens every time. So we're really interested in approaching these types of phenomena as a way to understand it. We want to understand what are the rules that govern how things work. And so in order to approach that, we want to design experiments that allow us to tease apart those rules or those concepts that lead to the events that we're looking to understand. And so we want to be able to show that a stimulus produces a result over and over and over again, and that is, reproducibility.
And if you use unbiased stereology, there'll be a set of rules that you need to follow, and the rules are not that hard. We're not going to go into all the rules for all the probes, but we do have other sources to help you with that. That will get you an unbiased estimate if you follow these rules so that bias doesn't creep into your sampling. You also need to think about how much to sample, and that's where the precision comes in. And if you can be unbiased by following the rules and do the right amount of sampling to get to precision, like Sue says, we can get reproducibility. The precision and the rules for bias are not going to be the main focus of this talk. What we're going to try to do is let you know how to pick a probe, which one to use.
Right, and stereology is a great quantification method because it makes no assumptions of the size, shape,